Viewers, and welcome back to For Final Maths class. Today we are going to move on to a new topic called integration. And in my previous videos we did look at differentiation and a lot under it, okay, the subtopics that comes under differentiation, which they all come under calculus, okay. So having done with the differentiation, today we are moving on to integration. Now the integration is the process of reversing differentiation, okay. So if you have something in the differentiation form and we are reversing that particular expression back, we use the process called the integration to reverse an expression in differentiation form back to the integration or back to the original expression, okay. Now the process of integration reverses the process of what? Differentiation, which I said earlier. The process of finding a function from its derived function is called integration. An example is if you have y to be equal to 3x squared. The derivative of this particular expression is dy dx, which will give you what? 6x. All right, so this is the differentiation form of what? This particular expression. Now if I want to have the integration of this expression or the integral of this expression, you know, it will bring me back to what? Y is equal to 3x squared, which means that I have reversed this differentiation expression back to what? Its original what? Position. And how did I get back to here? I used the method called integration to get back to what? The original expression, okay. So does the integral of 6x, which is this, is 3x squared, and that is what? Integration is the process of moving from dy dx to what? To y, okay. So the process of moving from dy dx to y is what we termed as what? Integration. Now the first thing that we will have to look at is integration. It is used to sum different expressions, or you know, subtract different expressions. All right, so maybe you have an expression in this form, which is 3x squared plus 4x minus maybe 2. All right, we can use what? Integration to do the summation and then the differences involved in this expression. All right, and then in the integration we use elongated s. All right, we have a certain s, but we use the elongated form of s to show that we are doing what? Integration. And this is how the elongated s is written. So when you see this attached to any expression, it means what? We are differentiating, we are integrating the expression. Now the variable of integration is shown by adding d after the function to be integrated. All right, now the variable that we are differentiating with respect to, it is shown by adding d to the variable. So for instance, if we are differentiating this expression and we are integrating this expression, to show that we are differentiating with respect to x here, we attach this expression with a variable which is d attached to what? The variable that we are differentiating with respect to. Thus, if we have 2x and we are differentiating it like this, all right, so we attach d and x to it, which shows that we are differentiating this with respect to what? X. So this is read as the integral of 2x. All right, we differentiating with respect or integrating with respect to x. Now the third point is, in order to allow the possible presence of a constant, whenever the process of integration is performed, a constant c is added to the results. All right, that is, if we are integrating, in order to show if the integration that we are dealing with is an indefinite integration, we add a constant c to the expression that we will obtain after integration to show that the expression, or to show that the integration that we are dealing with is an indefinite integration. So for instance, if you are differentiating these 2x, we will be obtaining x squared plus c, to show that this expression at all is what? An indefinite expression or an indefinite integration. Now the next point is also that the function to be integrated is called the integrant, and c is the arbitrary constant of integration. So this function that is involved in this expression that we are to integrate it is called what? The integrant. And then the c that we have added after integrating the function is called the arbitrary constant. The arbitrary constant, which is what? The c that we bring after integrating an indefinite integral. All right. Now, the next point that we have to also take note is the process of integration where the constant of integration is not known is called the indefinite integral. So when you are differentiating a constant which we don't know the limit of that integration, okay, we call or we term that particular integration as what? Indefinite integral. So that is the few points that we will have to note when we are dealing with what? Integration. Now the next thing that we have to look at is the general solution of integration. When we are dealing with integration, how do we deal with it, or how is the general the general solution that we have to go about in order to obtain our integration process or our integration itself? So the general solution of integral of the form ax to the power n is given by here. What you do is this n is the power of the of the variable that we are differentiating with respect to. So that n, we will subtract 1 from it, and then the results that we will be having, we will add 1 to it, and the results that we will be obtaining, we divide the whole of the expression with the 1, with that particular solution. Okay, so this is what I mean. So you have ax to the power n plus 1. Then this n plus 1 that we have obtained from the power, we divide all the expression with that solution, which is what? The n plus 1. So that is the general solution that we have. And if the integration that we are doing is an indefinite integration, meaning it doesn't have a limit, what we do is to add c, which is the arbitrary constant, to the solution that we have obtained. So what did we do? When you have an expression like this and you are integrating, all you need to do is to add 1 to the power of the variable that we are differentiating, we are integrating with respect to, and then we divide the whole of the expression that we will be obtaining by the solution of the power that you have plus the constant of integration, which is the arbitrary constant, since the integration that we are dealing with is an indefinite integration. Now, we have certain key points that we have to also take note when we are dealing with integration. That is, if we are integrating a constant, all right, say if you have a and we are to integrate a, you will be obtaining ax. All right, if you are differentiating a where a is a constant, you should be obtaining a x. All right, and if it is with respect to x, so we have to know that it is with respect to a, you have to obtain what? Ax. If it were to be differentiation and you are differentiating a constant, that we learned in our previous lesson, you will be obtaining what? 0. When you are differentiating a constant, you will be obtaining what? 0. But when we are integrating a constant, you get that particular constant times the variable that we are integrating with respect to. The reason is we assume that this a is attached by x, but that x that we are differentiating with respect to is to the power what? 0. So the x here. All right. So here, as we did from the general solution, what you do is you have to take that particular constant which is there, then you add 1 to the power, because we know that this power x to the power 0 will give us what? 1. So 1 times a will still give us what? A. So we know, or we assume that x is attached to it, but x is to the power 0, and x to the power 0 will give you 1, which will bring us back to this. All right, so with that x, you add 1 to the power, which is 0, so 0 plus 1 here. All right, here we give us plus c all over 0 plus 1. Okay, so with this, you will be obtaining ax to the power 1. All right, all over 0 plus 1 will give us what? 0 plus c here. All right, so this will be equal to a times what? X to the power 1. We have ax divided by 1, so we still have what? Ax plus c. And this is why when we are differentiating a constant, we have ax to be our solution. Now we are going to look at indefinite integration. Okay, remember I told you that when we have two types of differentiation, the integration. We have the definite integration and then the indefinite integration. The indefinite integration is the one which we don't know the limit of the expression. Okay, the integral or the expression that we are going to differentiate doesn't have any limit on it. So after differentiation, what we added to it is a constant c, which shows that we don't know the limit of that particular differentiation that we did, or that particular expression that we just dealt with. Now we have these few questions that we will use to elaborate or evaluate the explanation that we are, or to better our understanding, or to further our understanding and show what we really mean by what indefinite integration. Okay, now with the general solution that we learned, if you have an expression like this and you are to integrate, what you do is the power, you add 1 to the power, then you divide all of the expression by the power, by the solution of the power that you have. Then you add c to the solution, which shows that we are dealing with indefinite integration because it does not have what any limits so far as the integration expression is concerned. So now what did I do? I took the variable and then the power, I added 1 to the power, and then I divided the whole of the expression by the power that the solution of the power that I had, plus the arbitrary constant which we have. Okay, so here the solution will give us x to the power 5 divided by 5 plus c, and this will be the solution for this particular integration. Okay, so now the next one is just like the way we did with this one. You have 3x to the power 3, then you add 1 to the power all over 3 plus 1 plus your arbitrary constant, which is c, because we are taking off this integral symbol. Okay, so this one will give us what? 3x to the power 4 dividing what? 4 plus our integral constant or arbitrary constant, which is c. Now the third question, with that one too, you know, we have 3 terms in this expression. We have 1, 2, 3 terms in this expression, so we will integrate them one after the other, term by term, with considering what the operational signs that is separating the terms. Okay, now when we take the first one, we will be having 3x to the power 2 plus 1 all over 2 plus 1, then plus 2x to the power 1 plus 1 over 1 plus 1, okay, minus 5x to the power 0 plus 1. Remember, I told you when we have a constant, we would have to add 1. We assume that there is x there, so you have to obtain what the constant times that particular power, all right, or that particular variable that we are differentiating with respect to. So your arbitrary constant will come plus c. Okay, so from here we have 3x to the power what? To the power 2 plus 1. So we have 3x to the power 3 all over 2 plus 1. We have 3 plus here too we have 2x to the power 2 over 2 minus 5x over 1 plus c. Okay, when you look at the expression very well, this 3 will cancel this 3 and we'll be left with what? X to the power 3 here plus these 2 will cancel these 2 and we'll be left with what? X squared minus 1 will go into here, give us what? 5x plus our arbitrary constant c, and this will bring us to the end of the solution for the third question, and to the solution of all the 3 questions that we just gave the example, or that we just gave as an example to better our understanding. So without wasting much time, we will also look at few examples on the definite integral. Now we are moving on to definite integration. Okay, how to differentiate when the limit of the integration is given to you, or the limit of the expression that you are dealing with is given to you in the question. Previously we did with the indefinite integration, which here the limit of the integration will not be given to you. Okay, but with the indefinite integration, or with the definite integration, sorry, the limit will be given to you. So with that one, we have, it's almost the same as the indefinite integration, but with the definite integration, there won't be any arbitrary constant that will be introduced into the expression afterwards, solving for it. So because we have what? The limit of the integration, you will just put in the limit. It means we know the limit, so we won't put the arbitrary constant into the expression. So with this, you will be given the integral of that function, all right, and the limit will be given to you from a to b, all right. The lower one, which is the a, is the lower limit, and then the b which is at the upper is the what? The upper limit. Okay, then the integral, the function will be given to you, and then what we are differentiate or integration with respect to will also be there. Okay, so here you will see that we have obtained what? The derivative of the function given to us in the expression, which means we have differentiated it. So, we have integrated it. So after the integration, then we put the expression that we have obtained after integrating the function, we put it in the big bracket, then we put the limit there. After that, then we substitute the values of the limits into the expression that we have obtained, which is the derivative. Okay, so here this f prime of x means that we have differentiated what? The f of x here. So we'll be obtaining what? F prime of b. We will obtain f prime of b minus the f prime of a. So this is how we do it. So with the upper limit minus what? The lower limit. Though all that we need to do is what? After integrating the function, you just substitute the values of the limit into the expression. Now we will take few examples and then we see how this particular. Now here we are going to look at an example on what we just explained here earlier. Okay, so now we have this, the integral limit from 1 to 3 of this expression or of this function here, which is 3x squared plus 2x plus 4. We're differentiating with integrating with respect to what? X. Okay, so all we need to do here is open up a big bracket. Okay, then you integrate them one after the other. Now when we integrate this, we'll be obtaining x to the power 3. Okay, plus when we integrate this one too, we'll be obtaining what? X to the power 2. And then when we integrate the 4, we'll be obtaining 4x. Then we close the bracket, then we bring our limit there from 1 to 3. Okay, so just like we did with the integration previously, that is how we just did it. So this one will be to the power x 2 plus 1, and then all over 2 plus 1, so it will be 3, and that 3 will cancel this 3. The same thing will apply to this. All right, these 2, the divided by 2 will cancel these 2, and it will left a 4x squared, and here too, you know how we did it. Okay, now from here then we introduce our limits into the expression. Okay, first of all we will introduce the upper limit minus, then we introduce what? The lower limit, just like we did here. Okay, so we take the whole expression, which is x to the power 3, so we introduce this, so it will be 3 to the power 3 plus 3 to the power 2 plus 4 times 3. Then we close this bracket minus, we open the bracket again with the same expression, but here we will place 1 in place of what? The x. Okay, so it will be 3 to the power 1 to the power 3 plus 1 to the power 2 plus 4 times 1. Okay, so we close the bracket here too. So from here, now 3 to the power 3 will give us 27. So it will be 27. You open the bracket anyway. 27 plus 9 plus 12. Then minus, you open the bracket. 1 to the power 3 will give us 1. Plus 1 to the power 2 will give us 1. Plus 4 to the 4 times 1 will give us 4. Okay, from there, this will be equal to 27 plus 9 will give us 36. Now 36 plus 12 will give us 48. Okay, so we have 48 minus 1 plus 1 will give us 2 plus 4 will give us 6. Okay, so this will be equal to what? 42. All right, so with the limits, with the integration which has a limit, you will obtain what? An absolute value or a value or a whole number, which will be your solution, because we know the limit. Okay, but if it were to be the indefinite integration, which we do not know the limit, that one you will obtain the variable or the solution in terms of what? The arbitrary constant, and then the variable that you are integrating with respect to, okay, which is the x. All right, now we have the second question on the board, which says we should integrate with the limit from 1 to 2 of x squared minus 2x plus 2 dx. Okay, we are differentiating with respect to, we are integrating with respect to x. All right, so here what you do is you open your big bracket just like we did before, then you integrate this one. Okay, when you integrate this, you have x to the power 3 over 3 minus, when you integrate this, you have x to the power 2 plus, when you integrate the 2, you have what? 2x. Then you introduce your limit, which is what, 2 and 1. Okay, the upper limit being 2 and the lower limit being 1. Okay, so from here all you need to do is to substitute your limits into the expression. Okay, so here we have what, 2 to the power 3 over 3 minus 2 to the power 2 plus 2 times 2, then you close it, minus, you open another bracket, 1 to the power 3 over 3 minus 1 to the power 2 plus 2 times what, 1. Okay, you close this bracket too. Now 2 to the power 3 will give us 8. 2 to the power 3 will give us 8 over 3 here, over 3 here, minus 4, then plus 4 again, because here will give us 2 to the power 2 will give us 4, and then 2 times 2 will also give us what, 4. All right, you close this bracket, then you open another one with this one. So here 1 to the power 3 give us 1 over 3 here, minus 1 here, then 2 times 1 will give us what, plus 2. Okay, so now with the first bracket we have 8 over 3, because this 4 and that 4 will cancel each other. Okay, so minus with the second bracket we have 1 over 3 plus what, 1 here. Okay, because this one and that one will give us what, just plus 1. Then we simplify this. Okay, when you simplify, the LCM is what, 3. All right, so here we have 8 over 3. Here the LCM is what, 3. So 3 will go into 3 one time times this, we have what, 1. Okay, then this one will, 3 will go, 1 will go into 3 times this, so we have what, plus 3 over 3 here. Okay, so now here we have what, 8 over 3 minus 4 over 3, and when you simplify this we will obtain what, 4 over 3. Okay, and this will give you the solution for the question on the board, and also it will bring us to the end of the definite integration so far as what, integration is concerned. Have a nice day.